if I draw the path along which suppose the particle is moving, okay, along which particle is moving. Suppose this is marked as A, the position at t equal to 0 second. Let this is the position B at t equal to 1 second. Let this is be the position C at t equal to 2 second. And let this is be the position D at t equal to 3 second. Okay. We have to calculate this displacement. If it is S1, we need to know this displacement S2, and we need to know this displacement S3. Are you getting me? S1 is the displacement during first 1 second, S2 is the displacement during second 1 second, and S3 is the displacement during last 1 second or the third 1 second. Okay. As because particle is continuing during the motion, particle is expected to maintain its acceleration, which is said to be 2 meter per second square in all three intervals. It is continuously moving with this acceleration. It is continuously moving with this acceleration of this 2 meter per second square. Are you getting me? Right. Now, relating to the initial velocity information, I can say absolutely at the starting instant this is u1, let it be 0. This information is known. Obviously, as because it is continuously moving with constant acceleration, so we know that whenever acceleration is maintained by a particle during motion, do you think that its velocity remains constant or it changes? No, that you are making a big conceptual mistake. I have said always, acceleration is defined as the rate of change of velocity. The statement, whenever the word is used, a particle is moving with acceleration, means it is taken into consideration. You must keep it in mind that velocity of the particle is definitely changing. In the direction of acceleration, velocity must increase. Particle is moving rightward, acceleration is also given rightward. That means along the acceleration is available in the existing direction of motion, means velocity will increase. Had it been given acceleration is appearing sometimes opposite to the motion, that time it is called negative acceleration or retardation. And in that case, during the motion, velocity decreases. We have used these languages several times now. So you should concentrate on this understanding. Whenever we say the term of acceleration available, means velocity must keep on changing. Here velocity must increase. So if we are known about the starting velocity which is 0, so definitely at the end of 1 second, that is at B, it must have some velocity value more than 0, because being it is increasing. What exactly we do not know. Similarly, at C, it can further have another velocity, let it be u3, which is again more than u2. And finally at D, it is having some velocity u4, which is further greater than u3. So what we can say u1 less than u2, which is less than u3, less than u4, like this. We can relate the velocities at this 4 instant. 0 second, 1 second, 2 second and 3 second. Clear? Now next part is displacement of a particle during its motion. Displacement of a particle during its motion under constant acceleration, displacement of a particle during its motion, and what kind of motion? Under constant acceleration, given by the formula S is equal to ut plus half at square. Are you getting me? S is equal to ut plus half at square. Okay, this is the displacement finding formula for a particle when it is moving under constant acceleration, provided we know the t as the time duration. So I can further explain about the terms u. This is initial velocity of the time duration t. Time duration t, the whatever the time duration what we are going to use in the formula, for that duration of time, u will be the initial velocity of the journey. That means at the starting position. Are you getting me? For example, when I will, according to the geometry or diagram, suppose if I want to know the displacement AB, which I have shown with S1. So in the journey of AB, initial position is which one? A. B is the final position of the journey, A to B, yes or no? So if in the journey AB, which is being represented by S1, A being the starting point, so in the formula U, which is the initial velocity of a journey of t second or time duration t, so here in this displacement, in every displacement measurement, listen me carefully, in every displacement measurement you must have the clear idea about the starting position. And instead of u, you will only allowed to use the velocity at that starting instant. So in calculation, for the calculation of S1, which one is the starting velocity position A? What is the velocity information at A? 0. So I will use 0 into S1 is for how long? S1 displacement is for duration. Duration of his journey is 1 second. So I must use t as 1. Is that clear? Plus half into acceleration of the journey is 2 into time duration is 1. So I will use 1 square. Getting it? So the calculation of S1 is coming just 1 meter. You can check it out. It is just coming 1 meter because 0 into 1 is 0. 0 into 1 is 0 and 2 will get cancelled out here. So it is only 1. Yes or no? Is that clear? Since are you finding difficulty, then go to the other sitting position from where you can say it clearly. Is that clear?
Sir, why not 1 square?
In this part?
Yes.
Because the formula doesn't say is about to use the t square in the beginning part of the formula. In the beginning part of the formula is u into t, power of t is 1. And in the next part, half at square, their power of t is 2. So according to the formula, we will substitute the value and we will take, either we need to do a square or not, depending on the formula. A formula says that in the first part we are only supposed to use t, not t square. Then why should we do 1 square? So have you got this one? Now, similarly, if I want to calculate the next displacement, that is B to C, that is BC, that is the displacement in next 1 second, which is the second 1 second, right? So can I write down it is S2? So for S2, what will be the initial velocity I should write down?
1.
Try to follow whatever I have said and whatever I have done in the calculation of S1. What did I say? In any displacement, you must identify your initial position. When you are calculating S2, it is the displacement from B to C. So which one is your initial position? B. So velocity at B should be used instead of U. Because your second calculation is you are measuring the displacement from B to C. So B is the starting position of the second displacement. Yes or no? So you must use the value of velocity at B, which I have marked with U2, but unfortunately I don't know the numerical value of U2. That is a different issue. But according to the format, according to the limitation, I must go as the formula suggests me. So formula suggests me to use the velocity at B as the starting velocity for the next 1 second displacement. Journey from B to C is again of duration of how long? 1 second. So I should multiply 1 as the time interval. T in the formula is the duration, time duration for which the journey is discussed. Okay. So U2 into T plus half into acceleration still remains same there, that into 1 square. Are you getting me or not? So here we are getting it is U2 plus 1. So exact numerical calculation can only be known once I come to know about the value of U2. In question nothing has been said about U2. But what we can see in the geometry or in this as per concept, what we can understand relating to U2. U2 is the velocity at B. B is the position after how much time from the starting instant? 1 second. Can we know the velocity at B? Can we know? Do you have any idea that regarding knowing the velocity value of particle at B, that is the value of U2? Sirsha? I am asking that primarily to calculate S2 we are bound to use the velocity at B, that I have assumed as U2. But primarily we do not know the value of U2 as per the given information in the question. But now my question is, do we have any other idea to know the value of U2? Yes, there is a, see, between A and B, is it moving with the constant acceleration? Is the particle moving with constant acceleration from A to B? So in case of A to B, B is the final position, A is the initial position, and in the journey of A to B, is it moving with constant acceleration? It is always moving with the constant acceleration, so it is available in the first 1 second. So can we do this one separately for A to B? For A to B, can we write down acceleration is equal to velocity at B minus velocity at A divided by time taken to travel from A to B? Do you remember A was V minus U by T? We have done it. We have already used this formula, and there I have shown how to relate the two velocities in an accelerated journey. So an accelerated journey from A to B, where acceleration is constant. So can we relate the velocity at B and velocity at A using the interval with this formula? Yes or no? So for me velocity at B, I have marked it with U2, and velocity at A, which is already given 0, divided by time is 1 second. So can it help me to calculate the value of U2? Yes. The value of U2 is coming 2. Value of U2 is coming 2. So this result of velocity of U2, that we can substitute here. So therefore now S2 is 2 plus 1, that is 3 meter. So in first 1 second, the displacement of the particle was just 1 meter. In second 1 second, displacement of the particle is found 3 meter. Got the way of doing it? Now with this idea, can you calculate the displacement by the particle in the third 1 second, that is from C to D? Calculate the displacement of the particle in third 1 second, that is from C to D. Displacement CD, which is S3. So at C, the initial velocity that I assumed is u3, right? So I need to write down the displacement finding formula u3 into 1 plus half a into 1 square, yes or no? So again it will be, the result will be u3 plus 1. u3 plus 1 meter will be the displacement, and again we need to know about u3, right? I have already come to know about u2. So I can say the velocity u3 can be compared with u2 using this format again. So that we can write down for B2C. For B2C, there also acceleration remains same, and I can write down this is the velocity at C minus velocity at B divided by the time taken to travel from B to C. And in this part, acceleration calculation is 2, velocity at C is u3, and that at B was u2 divided by interval is 1 second, right? So that means 2 is equal to u3 minus 2 divided by 1, because we got earlier u2 as 2. So simplifying it, we can write down 2 equal to u3 minus 2. That means u3 will be 4 here. u3 will be 4 meter per second. So as we are getting u3 as 4 meter per second, so therefore S3 that was depending on u3 is 4 plus 1. So yes, it is 5 meter. Got it? So this is the way we can always calculate that means what are the most important thing that I have come to know by solving this particular problem. With this problem, we have come to know about one complete idea, that whenever you will be using the formula S is equal to ut plus half at square, then what are the most important points where you should focus on your learning? That is the value u what you are using in the formula, that should be the velocity information absolutely at the starting position of the displacement path, right? A must remain constant and t must be the time duration involved in that journey. Is that clear? Now this is one way of solving it. I will show you another technique, like using this, as I have calculated here part-wise displacement. First 1 second, second 1 second, third 1 second. When I am calculating it like that, for calculation of S1, A is my starting point. For calculation of S2, B was my starting point. And for calculation of S3, C was my starting point. So I was bound to know the velocity at B and C separately. That's why I took 2 additional steps of calculation. Isn't it? But without even, there is one more way, as because it is the continue motion and we are asking about displacement in continuity without giving any gap. So that's why there is one more technique that we can apply. As we know that we are only having the velocity information at starting instant t equal to 0. And suppose I don't want to do this additional calculation to know the value of u2 and u3. Then what I can do? Say another mechanism. Have you written this much? Say, or for example, this was my journey. This was, suppose this much was S1, right? this one was S2, and this one was S3. It was something like this. This was A, B, C, and D. In every, throughout the motion, A is available as a constant in value, but velocity information is only available at starting instant. Yes or no? Velocity information is only available at this instant, starting instant. We don't have velocity information at B and C. And suppose I don't want to calculate the velocity at B and C, but I have been asked to know the successive displacements like S1, S2, S3. Okay? Then I will apply one trick. For A to B, I can calculate S1 using the initial velocity of A, that is 0. So it is 0 into 1 second plus half into acceleration into 1 square, right? I will do this one only. Yes or no? We have already done in the previous method also. So this calculation will come as 1 meter, right? Now next, instead of calculating the next displacement BC, suppose the next step what I'll do, I will calculate the displacement from A to C. Why I am doing this? Because I know the velocity. See, whenever I will go to calculate BC, so B will be the starting instant. So I am bound to use the velocity at B, but in the given problem, velocity at B is not given. Only I know the velocity at A. So I will use the velocity at A information at the starting velocity. So if I calculate the displacement from A to C, so I should write down it is S1 plus S2. Whatever the calculation I will do as a displacement from A to C, that will be basically S1 plus S2. Yes or no? In that case, in the calculation of A to C journey, A is my starting point. So I will again use the 0 as the starting velocity. Right? Yes or no? And what should I take the time taken in the journey from A to C? 2 seconds, correct. 0 into 2 plus half into acceleration throughout is 2 and time duration is 2, so 2 square. Is that clear? So how much I am getting? 0 into anything is 0. So I am getting here 2 gets cancelled out. 2 square means 4 meter. So I have got S1 alone 1 meter. I have got S1 plus S2 together is 4 meter. So from this to calculation, can I write down S2? This is S1 plus S2 minus S1. Can I do this? From the calculation of S1 plus S2, if I subtract the first displacement S1, whatever it will remain, it will be the displacement of S2 alone. So that means 4 meter minus 1 meter, that is 3 meter. So I have got the exact value of S2 even without bothering to know about the velocity at B. Got my point? Similarly, in the third part, if I calculate the displacement of the journey from A to D directly, A to D means it is S1 plus S2 plus S3, such that again the velocity at A to be used as the starting velocity of the total journey. So it will be S1 plus S2 plus S3, and that calculation will again be 0 into this time will be 3, because A to D it is total 3 seconds plus half into 2 into 3 square. Yes or no? So is it coming 9 meter? So S1 plus S2 plus S3, we are getting it as 9 meter. So therefore S3 alone S3 alone can be this total calculation S1 plus S2 plus S3. From that, if you subtract S1 plus S2, that is 9 minus 4, 5 meter. Got it? So this is another idea to know the successive displacements without calculating the velocity at intermediate points. So there are two different methods, right?